Well, I appreciate being able to be here, have this opportunity to kind of talk about water optimization. So I'm Tony Richards. I'm the Water Optimization Program Manager at the Utah Department of Agriculture and Food. Say that 10 times fast, right? So just a little bit of an introduction. So the Water Optimization Program, its mission, its vision is, if I were to put it in a short phrase, it's resilient agriculture. That's what we're looking for. It's being able to work with agriculture and improve their infrastructure, improve their management around agricultural water use, and create a more vibrant, more resilient agriculture while we're using these water resources that are so important, as we've already kind of talked about. So how we do that in the program is we are a voluntary cost share program. So agricultural producers, canal companies, they participate in the program. They actually have to put up about half of the cost of their project. So we don't pay for everything, they pay for part of it. So this is our dashboard that we have. That's publicly available. If you go to our website, I'm sorry, that's a long link, but find it there. You can look at different areas within the state. You can look at different watersheds. So this is technically selected on the Great Salt Lake watershed. If you see, we have 499 projects so far that we have funded under the Great Salt Lake watershed. Okay, of those projects, we've actually completed 218. Of those completed projects that have reported, so part of the program is they have to report their water use for 3 years. We have about 47,000, acre-feet annual diversion savings. And Blake did a great job about talking about diversion depletion. So that's actually measured through a meter, all right? So there are a lot of projects out there. And like I said, it's both canal infrastructure as well as on farm. So I want to kind of just touch on a few of the project types that we work with. So one of it is either replacing current pivots or wheel lines with pivots. And what we focus on is what's called LISA or LIPA type pivots that are low elevation, precision application, or surface application. So these pivots, their application is really close to the ground, so you reduce a lot of water, evaporative loss, wind loss. So it's a more precision application and reduces some of those evaporative losses that we don't want to see. We want to get the water to the crop. So that's one type of project that we do. The other one is subsurface strip. You may have heard of some of these projects. This is quite new to Utah. We don't have a lot of subsurface strip in the state before the program started. We have some projects that have taken this on. It's a very new technology in the sense of Utah, not necessarily in the technology itself. So basically a drip tube is installed underneath the surface of the field, permanently put in there, and it applies water to the root zone directly. So a lot of the losses that would be from a sprinkler type application or something is not there again. So it reduces some of that and drops the overall water application needed for that field. And at lunchtime, if you want to talk about questions, these systems are great, but they also have a lot of challenges. Some of the newer ones, it looks like those videos won't play. Automated surge. So this is actually where we still continue to use flood irrigation, but we have the option of automating it, and the surge component is how we irrigate. So instead of starting water onto a field and trying to irrigate the whole thing at once, you actually do it in set phases. And so you water so far, you go to another field, you come back, water a little bit more, and it takes the hydrology of how water moves through soil and uses it to the benefit to be able to do more uniform application across the field instead of flooding the front part of the field trying to get water to the end of the field. So this utilizes solar-powered, cellular-controlled valving and things like that will do these cycles and automatically do it, so a farmer's not out there trying to do it on the field themselves. Give you an example. It would take changing about every 90 minutes for some of these. So a farmer can't run out to that field and do that every 90 minutes. They would never have anything else they could do. So this puts it in the realm of automation, and so we can do more high-level management, okay? Now, Jim is here, so if you want to look at the scale of how big that pipe is, just go up, stand next to him. So canal linings, pipings, enclosures. So we do a lot of work with canals to try and reduce some of the seepage losses, especially in areas that it's excessive seepage loss outside what would be kind of a typical. It can be cement, polyliners, that kind of stuff. So we do a lot of canal projects that way. A lot of our diversion savings come from this component. telemetry and measurement. You don't know what you don't measure, right? So all of our projects are required to put measurement in. So whether it's an on-farm project or a canal project, they do have to have metering. And then, like I said, they report for 3 years after the project is completed. So telemetry and measurement, we thought this was going to be a big problem when we started, that a lot of producers were going to kick back against this. And in fact, they really like it. It gives them the knowledge of what they're using. It helps them do a lot of management. It's a tool, and they're realizing how good of a tool it is. Now, if you notice, that gate on the end, so this is Bear River Canal. This is one of their end gates. This is called a radial gate. So it not only controls the flow of water, it actually measures it as it's controlling. And they can essentially set a level and say, I want this much water spilling off the end of that canal to manage it, and it will move that gate up and down automatically to maintain that flow. So these, not only for the management of the canal, though, it also gives the measurement of what the canal is returning back into the system. So as Marcel pointed out, a lot of these canal systems on the end of the Great Salt Lake, near the Great Salt Lake, are going to be a critical part. These are critical tools that are going to give them the management to be able to be part of the solution. So we've done a lot of that work as well. Why does this matter for the Great Salt Lake? Probably all of us in this room have heard that. Agriculture uses 80% of the diverted water. So a lot of that has been used in a negative context, that agriculture uses too much. What I would like to say is that these kinds of projects, okay, this improved efficiency and management creates opportunity and options for agriculture to participate, okay? So not only do we have 80% of the diversion in agriculture, you have the opportunity through such programs like this to work with 80% of the water that's being diverted. It's an opportunity, not necessarily just looking at it on the negative side. So we have a lot of options that we create inside this. WaterOp is that tool that gives a producer that option to keep going, that keeps their operation in viability, whether economically, productivity-wise. So, for example, an option would be if a guy increases one field with water optimization, makes it more efficient, more productive, more resilient, then he can sit there and go, you know what, I have this other field over here that isn't producing what I need necessarily. It's not the greatest field. Maybe I can lease the water off that field because I can get the production I need for the forage I'm producing for my livestock, whatever it may be, off this other field. Okay, so that's where water optimization fits within this, overarching effort to try and improve the Great Salt Lake. And I'm